Assalamualaikum and selamat sejahtera. My name is Hazim Ahmad bin Hazizi and my metric number is 2310911112. And the two other of my teammate name is Muhammad Fikri bin Rosli, metric number 2310911147, and one Faiz Hakim with metric number one Muhammad Faiz Daniel bin Yusri, metric number 2310911207. Okay. Today I'll be doing the demonstration for the SLC, which is the sequential logic circuit design. And today I'll be presenting the finite state machine with the responding circuit. Okay, before I start, I just want to inform that the finite state machine that we are using are more model. Why? Because for our transition state, it only depend on the input value, which means that the output is static. Only the input that determine the transition state. From, for example, from state 1 to state 2, the input will be determine the direction of the next state. Okay, for the brief introduction for my finite state machine. Okay, as you can see, in this finite state machine, we have 4 states, which is state 1, state 2, state 3, and state 4. State 1 is actually the safe level water level, the safe water quality level for our project. Okay, and the state 2 is the unsafe water quality level for our project. State 3 is the dangerous level quality for our project. And the state 4 is the deadly water quality that our project detect. Okay, so as we can see, there is 3 input, which is A, B, and C. A represent the pH sensor, B represent the turbidity sensor, and C represent the DO or dissolved oxygen level sensor. Okay, and then we also have 2 type of output, which is the 2-bit monitor and 1-bit buzzer. The 2-bit monitor, which has X as its first bit, as its first bit, and Y as its second bit, and then Z is for the 1-bit monitor, 1-bit buzzer sense, 1-bit buzzer output. Okay, then let's start the demonstration as I have explained what are the variable means. Okay, we start our simulation. Okay, we are starting at the 0, at the state 1, which means we are in the safe level. Let's say we want to go to the next condition, which is the unsafe level. So one of the sensor must detect a dangerous level of quality. Let's say the pH level when either the pH level goes above 8 or goes below 6. Okay, then when this sensor detect that this sensor detect that there's one dangerous level, so it goes to the next transition state. Same with if the turbidity detect the dangerous level, same state occurs. Also same for the C, which is the dissolved oxygen level. Same state occurs. This is because the transition state from S1 to S2 is actually A bar, B, C bar. A, B bar, C bar, or A bar, B bar, C. So this is the transition state from S1 to S2. Okay. Then let's say we want to move from S2 to S3. From unsafe level to dangerous level, we need to activate two sensors in order for S2 to go to S3. Let's say we have C and B. So we goes back, two sensor activate, we goes to state 3. And then let's say use of oxygen and pH level goes to state 3. Use of oxygen, no, pH level and turbidity level goes back to state 3. Okay, so when one input is activated and the other one input is activated, then we go from S2 to S3. So we can conclude that the transition state from S2 to S3 is actually A, B bar, C. Is actually A bar, B, C, A, B, C bar, A, B bar, C. Okay, then let's say we want our output to be X1, Y1, Z1, right? So the state that occurs is the inputs that the input should be A, B, and C. Then we can see it transitions straight right back to S4. Okay, so we can conclude that the transition state from S3 to S4 is actually A, B, C. And then let's say you want to transition back from the deadly level, which is S4, to the safe level, which is S1. So we can show that none of the sensor activate should be the S1. This is because the transition state for S1 from S4 to S1 is actually A bar, B bar, and C bar. So this is the transition state from each state to the other state. For conclusion, in order to create the state for the Moore model, we need to include the input for its transition state, and for each state must have the output value. For example, for the safe level, we have the safe output, that is z equals to x equals to 0, y equals to 0, z equals to 0. And then for the second state, x equals to 0, y equals to 1, z equals to 0 for the unsafe level. And then x equals to 1, y equals to 0, and z equals to 0 for the dangerous state. And lastly, x equals to 1, y equals to 1, and z equals to 1 for the deadly state. Okay, then we also need to include the input value depending on the sensor. For example, A is pH level, B is the turbidity level, and C is the dissolved oxygen level. So we know when none of the sensor detect any dangerous level, it should go to the state 1. If one of the sensor detect a dangerous level, it will go to the state 2. If two of the sensor detect a dangerous level, it will go to state 3, which is the dangerous state. And lastly, if all of the sensor detect a dangerous level, it will activate the monitor to mention that it is a deadly level, and the buzzer will be activated. Okay, so for the conclusion, that is what we required in order to create a JK flip-flop circuit based on the FSM model. As we can see, here is the output and here is the input. Okay, so that's all from me. Assalamualaikum warahmatullahi wabarakatuh.